Hello and welcome back. I hope you had a wonderful weekend. So we are going to finish this unit tomorrow. We'll take the logic test tomorrow. I still have 33% of you guys who have not taken the practice test. So if you haven't taken it, let's do that today. That'll give you an idea of how you would do on the test if you took the test today. Okay. Also, I decided I was going to be nice. I was going to give another assignment today, but instead I thought I would give you time to either study or to get caught up on your homework. Keep in mind the Unit 2 assignments are all due tomorrow whenever we take the test. So if you have any assignments that were incomplete or you did not get full credit for, you can go back and resubmit those for full credit up until tomorrow, Tuesday. Okay. After that, I won't take any more because we need to move on to Unit 3. So if you have finished taking the practice test, you can go through the solutions with me and you can see what you did wrong. All right, so on number 1, this is actually the most missed problem. We want to use the diagram to the right over here. Let me fix those real quick. All right, so it says that angles ABH and CBH are a linear pair. Well, first we need to know what is a linear pair. So a linear pair is a pair of angles that forms a line. Remember, this was also the most missed problem, or at least involving this term, a linear pair, was the most missed problem from the last test as well. So a linear pair looks something along the lines of this. It's a pair of angles that add up to a straight line. So that means there's two things. They're adjacent to each other, meaning they're touching, and they're supplementary, which means they add up to 180 degrees. So if you look over here, we have angle ABH, which would be this angle right here, and CBH, which is this angle right here. Now this tells us that we have a right angle, meaning the vertical angle is a right angle and the supplement's also 90. So both of these angles are right angles. But the question for it being a linear pair is not are both these angles right angles, but are both of these angles, are they a linear pair? Meaning, do they add up to 180 degrees and are they adjacent to each other? And they are. So this is in fact true. Okay, but the justification is because they're adjacent supplementary, because that's what it means to be a linear pair. It's not that they combine to be right angles. In fact, they don't combine to be a right angle. They're not a right angle. They are both themselves right angles, but they don't add up to 90. That would be complementary, not supplementary. So quite a bit of confusion on that one, but just make sure you know your vocab. So supplementary, complementary, linear pair, vertical angles, all that good stuff. Midpoint, bisector, you know. All right, number 2, only 12% of you guys missed this one. It says segment CB is parallel to line L. So line L is here. That's a cursive L. There's no point next to it. That's how you know that's referring to the line. And CB is going to be this segment right here. Well, line L and CB, they are not parallel because they intersect, right? So what does it mean for two things to be parallel? It means that the two lines, or the line, the segment, do not intersect. Well, they do intersect, and they intersect at point B. So this would be false because they intersect at point B. Their intersection does form a right angle, but that's not why they're not parallel. It's because they intersect at B that makes them. All right. And CB and line K, those two are actually parallel. So I'm not sure what you guys are doing there. All right, so on number 3, there was actually a typo in the problem. We should have started off the series not at 1, but at 0. And then you would notice each time we were adding 7 additionally. Now, this mistake that I made didn't mess up a lot of you guys because you still were able to figure out the pattern. So plus 7 would be 14, plus another 7 would be 21. So what would come after that would be 28. So most of you guys were able to figure it out, even though it started off on the wrong term. All right, number 4, based on the pattern, what's expected to be next in a sequence? So we have 3, 9, 27, 81. So each one of these is going to be 3 times bigger than the previous one. So this is a geometric pattern with a common ratio of 3. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, and then 81 times 3 is going to be our answer, which I believe is 243. All right, so most of you guys figured that one out as well. Good job. Determine if the following conjecture is true or false. If false, give a counterexample. So the conjecture says that if n is an odd number, then n has to be equal to 5. So is that true? If it's an odd number, does it have to be 5? No. So the way that this would be shown visually is that odd numbers, if it's an odd number, then it's a subset of 5. So are all odd numbers 5? No, that's actually backwards. So the converse of this statement would be true. If n is equal to 5, then it has to be an odd number. That would be true, right? So if we switch the order of these two, made the converse, if it is 5, then is it a subset of odd numbers? Yes, because there are other odd numbers that are not 5, right? That's what makes 5 a subset of odd and not the other way around, because there are other odd numbers that are not 5. So this is not true, and the reason this is not true, the conditional statement is not true because of other odd numbers, namely any other odd number that's not 5. Okay, so our counterexample would be D. It's false because it's possible that n is equal to 7. That's a counterexample that proves this statement wrong, because if it's an odd number, it doesn't have to be 5. It could be 7. So that shows that it is not true. Number 6, determine if the following conjecture is true or false. If false, give a counterexample. If two distinct lines intersect, then they intersect in exactly one point. So this statement is actually going to be true. So let's say that I have two lines. So let me draw some lines here. So here I have this line and this line here, and they are distinct lines. Distinct lines means they're unique, meaning they're not the same line. Otherwise, they would intersect at all their points. So they intersect, and therefore they're going to intersect in exactly one point. That is going to be true. All right, so most of you guys figured that one out, which is good. Use the law of detachment to draw a conclusion from the given statements. So law of attachment, we start out with a premise. It says, for instance, if two angles are congruent, then they have equal measures. So if the first part of the premise happens, then it means the second part happens as well. So for instance, angle P and angle Q are congruent. Well, what did they just tell us about two angles being congruent? So if we have two angles like P and Q that are congruent, then we know that they have to have equal measures. So if angle P and angle Q are congruent, then we know that angle P and angle Q have equal measurements. So we show the measurements of angle P and angle Q by putting a little script or the little cursive M in front of it. So we're saying that the measurement of angle P is equal to the measurement of angle Q, which is how that would be read. So the answer would be B as in Bravo. So we don't know that they add up to 180. They're not saying that they are not equal measurements, and that we don't know that they're complementary either. We know that they are equal because that's what they told us from the law of detachment. All right, use the law of syllogism. So the law of syllogism is like the transitive property to draw a conclusion from the given statements. So if you remember the transitive property, that's something that looks like this. So if A is equal to B, and if B is equal to C, then we can skip over B and go straight from A to C. So here we have, if a number is a multiple of 64, then it's a multiple of 8. If the number is a multiple of 8, see how the B's are lining up here, then it is a multiple of 2. So we can go straight from multiple of 64 all the way to the multiple of 2 and skip over the multiples of 8 in the middle. So if a number is a multiple of 64, then it's a multiple of 2, so our answer would be A as an alpha. What is the inverse of the following conditional? So remember the inverse, we just simply negate it. We keep the order the same. So if a number is divisible by 10, then it's divisible by 5. That's a conditional. So to invert it, all we have to do is negate it. So if a number is not divisible by 10, then it is not divisible by 5. So not 10, not 5. So the answer would be B as in Bravo. On this one, if a number is not divisible by 5, then it's not divisible by 10. That's actually the contrapositive. So that would be if we switch the order and we negated it. So it'll be the contrapositive is what you gave me there. If a number is divisible by 5, then it's divisible by 10. That would be the converse, which is when we switch the order. So just make sure you don't get them all mixed up. The easiest way to remember is that the converse is like shoes on the wrong feet, so we just switch the order. The inverse is going to be negating it, and the contrapositive, which is the longest one, we do both the inverse and the converse to it. So we switch the order and we negate it, which would be this one right here. Okay, so what's the contrapositive of the following conditional statement? So we're going to switch the order and negate it. So we're going to start out with the Q term, but the opposite of the Q term. So if 8x is equal to 72, then we're going to start out with 8x is not equal to 72. Then x is equal to 9. It's going to be x is not equal to 9. So our answer would be C as in Charlie. So on this one, the converse would be just switching the order, like shoes on the wrong feet. So that would be A. That's what most of you guys got wrong if you got it wrong. And this was the third most missed problem. So again, just remember the difference between the converse, the inverse, and the contrapositive. What's the converse of the following conditional statements? Remember, converse is like shoes on the wrong feet. So all we're going to do is switch the order. So if you live in Dallas, then you live in Texas. So the converse would be if you live in Texas, then you live in Dallas, which would be B as in Bravo, which most of you guys got right. C would be if you do not live in Texas, then you do not live in Dallas. That would actually be the contrapositive because we're switching the order and negating it. And on this one, if you do not live in Dallas, then you do not live in Texas, that would be the inverse. So you mix up the inverse and the converse if you thought it was A. write the definition as a biconditional. So with biconditional, the main thing is that we are going both directions, and we show that by IFF, which is if and only if. So a composite number has more than two factors. So when we write the biconditional, we don't switch the order. We just keep it in the same order as the conditional statement. We just add the IFF, the if and only if, in the middle. So a composite number, it is a composite number if and only if it has more than two factors. So the IFF is in the middle, which would be C. So a number is composite if and only if it has more than two factors. Number 13, we want to justify in the two-column proof. We want to give the justifications for the steps here. So on the first line, this was given to us. Often the first line is just given to us and just a restatement. And then from there, we're combining like terms by adding the 2x and 2x to get the 4x. So this would be combining like terms. And then after that, it looks like we're subtracting the 4x from both sides to get the negative x here. So subtraction property of equality. So our answers are going to be in two parts. So combining like terms and then the semicolon, then subtraction property of equality. So the answer would be B as in Bravo. Number 14, identify the property of equality that justifies a statement. So they're actually already telling you that it's a property of equality, so that's kind of helpful. So we're starting out with P is equal to Q, then P minus R is equal to Q minus R. So what happened? What did we do to both sides? So we started with P and Q, and now we have P minus R and Q minus R, and they're still going to be equal. So what we're doing is we're subtracting R from both sides, so that would be the subtraction property of equality. Name the property of congruence that justifies the following statement. So here we have if segment XY is congruent to WX, then WX is congruent to segment XY. So if you notice, what we're doing is we're switching the order of the XY and the WX, and we're switching the order about the congruency sign. So that is going to be the symmetric property of congruence. So this is a symmetric property of congruence. Now, a commonly mistaken one would be the reflexive property. Now, the reflexive property is when things are equal to themselves. So if we said that XY, or segment XY, is congruent to segment XY, since it's congruent to itself, that's like the same thing as the baby is equal to baby, etc., etc. So, that's absolutely terrible. B-A-B-Y. Okay, so baby is equal to baby. Things are equal to themselves. In other words, A is equal to A. That would be the reflexive property, but the symmetric property is like the commutative property, but we're switching the order about the equal sign, or in this case, the congruency symbol. All right, complete the following proof. So given that angles 1 and 2 are complementary and that angle 1 is 35, prove that. Okay, so the first statement is given. That's just restating everything that was given to us up here. So our justification for the first part is just going to be that it is given to us. So if we look down here, it has to be either A or D because the first part's given. Then after that, it looks like angles 1 and 2 are equal to 90. That's because they're complementary. So this is from the definition of what it means to be complementary. So definition of complementary. Let me fix that. It looks a little better now. All right, so that would be definition of complementary. After that, they're saying that we're going to use substitution property of equality. So we want to substitute in the value for angle 1 is 35. So this part here would state that 35 plus the measurement of angle 2 is equal to 90. Because what we did is we substituted in the measurement of angle 1, which they told us was given, was 35. So that would be the second part. So the first part was given. And the second justification that we are having to fill in is 35 plus the measurement of angle 2 is equal to 90. All right, so our answer is going to be A as in alpha. All right, the last one, number 17. This is the second most missed problem, so let's go through it. All right, first thing is saying that measurement of angle BAC is equal to BAD plus DAC. So BAC, which is the whole thing, the big angle, is going to be equal to BAD plus DAC. So what we're saying is we have two angles that are adjacent, meaning they're sharing a common side. So we can add them up together to get the measurement of the big angle. So the big angle is equal to the small angle plus the other small angle. All right, so that property is called the angle addition property. So angle addition property. All right, just like the segment addition postulate, the angle addition postulate allows us to add angles together that are adjacent. All right, then we substitute the values for the two expressions, combine like terms, subtracted both sides by 40, and then we divide both sides by 6, which is division property of equality. And then the last statement, so we have 15 is equal to x, and then we're going to switch the order of both of these about the equal sign. So we're switching the order about the equal sign in the middle. That's a commutative property, symmetric property. All right, so the symmetric property of equality, it's similar to the commutative property, but we're switching the order about an equal sign. So we have symmetric and the angle addition postulate. So angle addition postulate and symmetric property of equality. So the answer would be D is in delta. So kind of all over the place on that one. This is not the segment addition postulate because we're not adding segments together. The segment addition postulate will look something along the lines of this. So if we had, always have to have 3 points there. So we have A, B, and C. The segment addition postulate would say that AB plus BC is equal to the whole thing, which is AC. Okay, so very similar to the segment addition postulate is the angle addition postulate, but of course here we're dealing with angles. So this angle plus this angle is equal to the whole thing. All right, so that was it, pretty quick. If you have any other questions, you can always join us for our live office hours at 11 o'clock. I would love to go over any problems you have there. If you aren't able to make it to the live office hours, you can always ask me questions over Google Classroom or send it to me on Remind. So I'll see you guys later. Hope you have a good day. Remember, we do not have any assignment for today. All you're doing is studying, getting ready for the test tomorrow, or finishing any incomplete homework that you have for Chapter 2. And get that into me by tomorrow, and I'll get it graded for you. See you guys. Have a good day.